So in this video, I will be describing crossed aldol condensation reaction. What is crossed aldol condensation reaction? So crossed aldol condensation reaction is the reaction where the two different aldehyde having alpha hydrogen or maybe one having alpha hydrogen, okay, and other may not have the alpha hydrogen, undergo condensation reaction in presence of sodium hydroxide base to form the aldol product or beta hydroxy carbonyl or aldehyde compounds are called the crossed aldol condensation reaction. So for an example, if you take acetaldehyde and propanaldehyde, when you treat by dilute sodium hydroxide, so for this reaction you may get the four different product. So why the four different product will be coming here? One acetaldehyde molecule will undergo self condensation reaction with another acetaldehyde molecule and is going to form the compound 1, okay, the first compound. Similarly, the second molecule propanaldehyde, okay, it will be undergoing the self condensation reaction between itself and will be forming the compound 2. Okay, similarly, okay, so similarly the acetaldehyde molecule, enolizable carbon of acetaldehyde molecule, okay, is going to do the nucleophilic addition reaction of the propanaldehyde and will be forming the compound compound 3. Okay, and similarly that propanaldehyde enolizable carbon that will going to add the nucleophilic addition reaction of the acetaldehyde molecule and going to form the compound 4. So here you can check that this is the crossed aldol condensation reaction. The two different aldehyde which have the alpha hydrogen. So we got the many mix four different okay, the mixtures of compound. But you want to avoid this kind of different many compounds, we can just limit to get one compound also. So what we can do, we can take, instead of taking the okay, aldehyde or ketone having okay alpha hydrogen, maybe other aldehyde or ketone, we can take it which doesn't have alpha hydrogen. For an example, if you take a cyclohexanone which is the enolizable hydrogen, and another molecule which is the benzaldehyde doesn't have any enolizable hydrogen. So in this case, when you treat these two molecules by sodium hydroxide base, the ketone, okay, so since it is enolizable hydrogen is there, so it is going to enolize, this carbon is going to do the nucleophilic addition reaction of another molecule of benzaldehyde and going to form this kind of product, mixed aldol condensation product. Similarly, if you take that example here, okay, so butyraldehyde, isobutyraldehyde, and when we react with the formaldehyde molecule, so this isobutyraldehyde compound have the alpha hydrogen, but the formaldehyde doesn't have any alpha hydrogen. So this isobutyraldehyde of the enolizable carbon is going to react with the formaldehyde aldehyde of okay, aldehyde group of formaldehyde and is going to form this kind of mixed aldol product. So if we take this kind of example where okay, ethyl benzoketone, so and react with that, okay, yes, isobutyraldehyde, then in presence of base, mild base, so it may form the this enolizable carbon of ethyl benzyl ketone react with the another molecule of okay, butyraldehyde and will be forming the this kind of aldol product. So these all are examples of crossed aldol condensation reaction. Okay, thank you for watching.